So I need to talk about one-hot encoding. I feel that I should. I assume that you have knowledge of the methods of convolutional neural networks, but you don't have experience. But I feel that I should talk about one-hot encoding. So this is a representative image for one-hot encoding, and you see that your dataset, we have cat dog dataset, and in this image you have color dataset, and in this color you see three categories: red, yellow, and green. And the first occurrence is red, so the left side of your uh, output data, this is the output data, or this is the Y. At the left side you see the first occurred class, and for the red to indicate your first element or your first row is red, and you have the three categories, you should write a matrix that is like 1, 0, and 0. This is for the red. And I see that the second element is also 0, is also red. I should repeat it. And also the third row has the yellow, so the yellow must be in the middle, and this is the way we are dealing with the outputs in deep learning or also in machine learning. So you see the green here, so you should label this element by 0, 0, 1, and also lastly for the yellow you should again use this element. But in our data we know that there are 12,500 images for cat, 12,500 images for dog. So what should we do? As you can predict, for the cat we need 1 0 matrix at that time, 12,000 time, and also for the dog we should add 0, 1 matrix 12,500 times, but we should check these numbers to label it. So now we will be preparing the our output data, but you see that there are numbers here, so we should label it according to this. But I don't believe maybe I can trust the cat image number. This should be only a representative or predictive number. So what should I do? I should get the size of image here, I should get the size of cat data and then divide it to the one elements or I mean y images element number. To do that I will do something like this. I know that let's print the cat data here. Now I see some line here, so let's say we should print the shape of cat data, and I see some number like that. I can do something like that. So cat data shape gives one line of number, and also I can divide it to this 224 multiplied by 224 multiplied by 3. So the reason to do that is our image consists of 224, 224, and 3 elements. So when I multiply these numbers, I get the elements of one image. 3 color channel, 224 pixel for height, 224 pixels for width. When I do that, I have some problem here. I know that. Let's try to convert it. Well, I have still problem. So let's run it by taking the first element of tuple. So I am seeing the number of 4.4, but there can't be exist 4.4 image. The thing that I love giving practical courses, I am solving my problem in front of you, so that if you will face a problem like that, you will be familiar with it and you will be solving it. So probably there are some problems in pill, and I need to check that, and also uh, I need to actually uh, create the cat and dog data again. This will be easy. In our slides we have uh, the codes. So in our prepared dataset we should delete until here, and we can delete here. So now we have a proper way to organize our data, and let's say that this is our new, not problematic method. So let's delete these cat tag data, these both datas, and then if we delete it and also do the same calculation uh, for the dog. Oh, sorry. When I print, I say I see again some problems because we didn't import MISC. To import it from SciPy, we need to import MISC. So we have a problem now, but there are already created. We have already created data, empty data. Now we run that and we see that there are no problem in dog data, and if it's the cat data case, I probably forget to add. For the cat data case, let's check that. When I run that, there is no problem in both cases. So I know that there are 6 and there are 10 images in these NumPy folders. So now I can create a labeling data. So I know that NumPy, I know that my labeling array is for cat. For cat is this, and also let's say that it is cat label, and to multiply this, I can do something like that. I can use NumPy's tile function and get cat label. Let's say this is cat output. NumPy with NumPy tile. If I say 1 here and print cat output, I will get only 1 0. If I write here 2, I will get 1 0 1 0, and if I write it the number of elements in the cat data, I can create the label of images that corresponds cats. So when I run that, I see that float object cannot be interpreted as integer, so I don't have to do that. And when I run that, there's another problem. because the value is 6.0, we shouldn't write that here. We should make the integer the result of this. I mean, result of this question, or result of this code. So when I run that, I will be seeing the corresponding output for the cats. And if I do it for dog label, and if I say that 0, 1, and also if I say that this is dog data and this is dog label, so there won't be a problem for sorry, so there won't be a problem in labeling our data. I'm seeing the correct number of elements in each classes. So then I should save it, then I should train it with Keras, but in I need to show a Keras function to do that easily. To do that, I will be using a function, an example of image data generator, and it should include a convolutional neural network, but it is only for educational purposes for Keras function. So we will be talking about Keras function in the other section.